So today we're going to do the Pythagorean Theorem. Sorry about that. And in the YouTube video you watched, this was the very first proof of the Pythagorean Theorem, where you had the squares, and I liked the one also where they showed the copies of the triangle and the blank spaces, where this one equaled these two as well. So this is more of a grid view so that you could see that the sides of these squares equal the sides of the triangles. And if you find the area of a square, that would be b squared. So that's where you got the side B times side B equals 16, side C times side C equals 25, and A times A would equal 9. Because if you actually have the numbers here, you would have 3 squared plus the 4 squared, 4 times 4, would equal the 5 squared. And so if I actually calculated that, I would get 9 plus 16 equals 25. So the number of squares inside of each of these would equal this. So that's where they came up with the Pythagorean theorem. A squared plus b squared equals c squared. So if you wanted to, sketch something like this into your notes, you could, or if you don't need that, this is what you would need to make sure you know how to use. So then we talk about the what are these sides, A, B, and C in a right triangle. And the Pythagorean theorem only works for a right triangle, no other triangles. And this is for finding missing sides. Before the last section we found missing angles, this will be for finding missing sides. Well, there's 3 sides. Let's start with the first one, which is C. And that one we call the hypotenuse. This one is the longest side, and it's across from right angle. So the longest side, and it's across from the right angle. So if this is my triangle, my right angle, that one there would be the hypotenuse, okay? That one there, the longest side. It's always the longest side and always across from the right angle. The other 2 are kind of interchangeable. It really doesn't matter which one's A or B. They're called legs, and they form the right angle. It doesn't matter which one you call A and which one you would call B. They're both legs, and they both form the right angle. So those 2 would be the legs, okay? So this formula only works for right triangles. So leg squared plus leg squared, A squared plus B squared is always going to equal C squared. So this is your Pythagorean theorem. So make sure you have that down somewhere. There's 2 more pages of notes, not super long, but some more words, definitions, and then some examples to make sure we know what we're doing. And so I'll do a couple of them. I'll do one with you, and then I'll have you try one where you pause it and do it on your own and see if you come up with the same answer. And then we're going to do some problems where we decide if it's a right angle or a right triangle or not. We know it's got 3 sides of and it's a triangle, but we have to determine whether or not it's a right triangle. Okay. All right. Sorry, lost my page. It was sitting right in front of me. All right, so on here, we're going to talk about legs again. Legs are side A and B, and they form a right angle. So if I make a big triangle here, we don't have to keep drawing pictures for each one. The hypotenuse is the C, and that's the longest side across from right angle. That's side C. And then we have the Pythagorean theorem, and that theorem is just that side A squared plus side B squared is equal to side C squared. All right, so that means if I know that theorem, I should be able to solve algebraically a missing side length. So this would be A, the other one that forms the right angle would be B, the one across from the right angle would be C always. So the first thing to do to solve this, and you can write it A squared plus B squared equals C squared, or you can write it backwards like they do, it doesn't really matter, is to plug in the numbers for B and C. So notice that for C they plugged in 22 and B they plugged in 20. So the first thing you do is plug in numbers for B and C because those are the two that we know. And once you do that, they are doing 22 squared on the calculator and 20 squared on the calculator. So if you don't have a scientific or graphing calculator, this is probably going to be the route you're going to need to do. So now once you do that, you have a two-step equation. So you will subtract 400 from both sides. Write a little neater. Then we get to where we say 84 is equal to A squared. Now remember, we want to find out what side A is, not what A squared is. We want to know what just A is. So when we unsquare from previous lessons, we would do a square root. So we would square root both sides. And you'll round it to just one decimal place if you need to, okay? So we're gonna find the hypotenuse. So these ones are finding C. I'm gonna do one, you do it with me, and then I would like you to try one on your own. If you have a graphing calculator, a scientific calculator that can do squares, I will show you how you can eliminate this step right here, where you have to actually square them. You should be able to go right from the squares to here. So I will show you that here. So we've got A squared plus B squared equals C squared. We know that A is 20 and B is 15 and it equals C squared. Now you can type in 20 squared and then 15 squared, or if you don't have a calculator that does that, you got to do 20 times 20 and you got to do 15 times 15. So then you'd have 400 and you'd have 225. So you can still do this without a square button. Don't think that you can't. So you could do, let's put it next to it. So you would have 400 plus 225 equals C squared, okay? Oops, sorry. The other way to do this, if you have a scientific calculator, is to actually type it in as squared and then just get your answer of 625. So that would be 625 equals C squared. Over here, that's still 625 equals C squared. We will unsquare with a square root. And so if you do the square root of 625, it actually comes out to 25, and we would label anything that has labels, okay? So I want you to try this one because it's finding C again. So you're going to write out the 11 squared plus 12 squared equals C squared. Remember, A and B are interchangeable. It doesn't matter which one you pick for A and which one you pick for B. All right, so pause it and try it, and then unpause to check. All right, so if I'm doing this with my graphing calculator or even a scientific calculator works, 11 squared plus 12 squared is equal to 265. So I've got 265 equals C squared. I'm going to square root it. So second square root 265, whichever calculator you're using, it says to round to one decimal place, so we're going to round to 16.3. So 16.3 is C, and what were those? Meters. Squeeze that label in there. Okay. Now on the back side, what we're going to do is find A and B, and then decide if, given 3 measurements, if it's a right triangle or not. So let's do 5 and 6. So we'll do 5 together, and whether it's A or B, you're going to do them the same way. So we'll do 5 together, and 6 would be one I'd want you to pause and try it on your own, okay? So we've got A squared plus B squared equals C squared. A is unknown, so keep it as A squared. B is 70, so that's now 70 squared. And C is 74, so that's 74 squared. Okay, you have to remember the square part. Now, if you don't have a calculator that has a second square button, you would have to do 70 times 70, and you would have to do 74 times 74. And so if I was doing that, over here, I would have A squared is equal to 4,900, or plus, that should be a plus, sorry. And that's equal to 5,476, okay? And then you would subtract both sides by 4,900, and you would get what you get. I'm going to show you that if you have a scientific calculator or a graphing calculator, that you, because it does order of operations, you could just type in 74 squared, and to get rid of 70 squared, I'm going to minus 70 squared on both sides. Oops, forgot the minus. Minus 70 squared. Okay. Oh, sorry. 74 squared minus 70 squared, I should just start it over, gives me 576. If I subtracted this, the 5,476 minus 4,900, guess what I got? The exact same thing. So I'm going to square root to undo it. So if I square root 576, I come up with 24. Now this one wouldn't need a label because there's no label in the problem. All right, so we're going to set it up. You got 14 squared plus B squared equals 22 squared. A squared plus B squared equals C squared. So pause it, do it the way you need to, whether you're taking away 14 squared on both sides or whether you're going to do the actual square roots first. That's up to you. So if I don't have a calculator with the power button, I would have to do 14 times 14 and 22 times 22 and rewrite this without the powers first. So I would have 196 plus B squared equals 484. Okay, you would minus 196 on both sides, right? And B squared will equal something, which is what we're going to get over here. Now, if you don't want to do that part and you have a square button on your calculator, you don't have to, but you have to remember you have to hit the squared. You can't subtract first and then squared. You actually have to do 22 squared minus 14 squared. You can't subtract 22 and 14 and then square it. That's not the correct order of operations. You'd end up with the wrong answer. 22 squared minus 14 squared equals 288. If I subtract this, I would get 288. Okay, so I got B squared on this side and 288 on this side because it did it for you. The calculator did this part for you. Okay, so remember, don't subtract first. You have to either multiply it by itself and then subtract. Okay, sorry about that little interruption. I had a phone call in the middle of making a recording. All right, so we are going to square root, second square root, the 288, and we are going to round it to 1 decimal place. Notice this one has a 7 after it, so that would round the 9 up. So that would actually round up to about 17. It wouldn't be exactly 17, so you have to be careful with that. And the last part, there are 3 side lengths. They're already given, but you have to determine whether it's a right triangle. Now remember, it's only a right triangle if the 3 sides can fit into this formula. Now, if these weren't labeled, how would I know which one's the longest one? Or which one's C? The longest one is C. So this one's nice. It labels it for you, but if for some reason it doesn't label it, because I'm not sure if it labels on your homework or not, it might. But if you ever come across three sides of a triangle and they're not labeled A, B, C, the biggest one is always your C. So we have to just plug these in, these A, B, and C into the A squared, B squared, and C squared. So A is 16, you put 16 squared, B is 30, so 30 squared, and then 34 squared. All right, if you do not have a calculator with a square button, you would have to do 16 times 16, you would have to do 30 times 30, you would have to do 34 times 34, and so over here, that would be 256 plus 900 equals 1156, and then you would just make sure that 256 plus 900 equals 1156, and if it does equal, that means it's a right triangle. If you have a calculator that has a square button, you could do 16 squared plus 30 squared, get the sum of 1156, and then you could do 34 squared and get 1156. So if the two sides are equal, then that's a yes, that it is a right triangle. So look at number 9. If you want to try it without me first and pause it and then unpause it to check it, you can. So we're going to plug in our A squared, our B squared, and our C squared. Whether you do this with the power button or not, that's up to you. But when I add this side up, it comes out to 1586. And when I put in 37 times 37, I get 1369. That is not equal. That means this is a triangle. It's just not a right triangle. Okay, that's all we were trying to find. Right triangle or not a right triangle. Okay, so you're going to then do your practice. And so on the practice, you're finding, the first section is finding C. So plug in your A and your B with your squared, add them up, undo them with the square root, and find C. These ones here and on the back are a mixture. Sometimes you're going to find A, sometimes B, sometimes C. The ones down at the bottom, oh, here they are not labeled. So if you're trying to decide if it's a right triangle or not by plugging it into A squared plus B squared equals C squared, you would know that the biggest side is C, and it doesn't matter which one's A and B for the other two. C is the important one to find. Make sure it's always the biggest one.